Good afternoon. Sorry, good morning.
Good morning, ma'am.
I can see only 12 students in the meeting. Previous lecture is over.
Yes, ma'am.
I will share the PPT for distillation. We will continue with that. Can you see the PPT? Slide दिख रहा है? Hello. Can you see the screen?
Yes, ma'am.
Okay. Yesterday we started with heat and mass transfer unit operation, and example we started with distillation. We studied the components of distillation. We started with the flow sheet symbol. So this is the flow sheet symbol for the distillation. In this symbol, you can see some other components are also associated with the distillation column. So the overall flow sheet symbol contains distillation tower. It is called as a fractionator or column. Then there is a cooler, condenser we can say, then accumulator and reboiler. So these are the components which are required for the distillation purpose. There are different designs of distillation column. So we studied that. Basically it is two types, packed column and tray column. So either the packed column are there are different packings. So it may be sieve packing, it may be such a ring type structure packing, saddle packing and so on, or it may be a tray column. So tray column may, the design of the tray is like this. It is called as a bubble cap tray. So through this bubble cap tray or pack column, the purpose is to provide the space for the separation and where the ultimate mixing of the vapor and the liquid phase, and so the mass transfer will take place. Okay, so it provides the space for the separation. With this structure, it becomes easy to transfer the mass. Then we studied in detail how the bubble cap tray works. So this is the arrangement for the bubble cap tray, where the holes are there, and on that holes you can see such sides. On that the cap is placed. Due to the vapor pressure, the cap get lifted, and because of that the vapor escape from this gap and it mixes with the liquid which falls on the tray. Okay, I will show you the video so that the idea will be more clear. So this is about the bubble cap tray. Next is sieve tray. Sieve tray means sieves, that is holes. Okay, so number of holes are more like this. यहाँ पे जो दिख रहा है, this is the sieve tray. So such trays are placed one below the other so that continuously the vapor is moving through these holes and it is moving up, whereas the liquid is falling down, and in doing so the tray platform is the space where there is a mixing of the liquid and the vapor, and thus the mass transfer will be there. There are different shapes for the packing. Okay, so these are some different shapes. So saddle hai, ring hai, structured packing hai, cuff packing hai. So such structures are placed depending on the application, depending on the nature of the feed material. The particular packing design is selected, or it may be a mixed packing. There are sieves also, saddles also, rings also, like this. So particularly the design is selected and the pack columns are made. Then we are going to video. I will show you some working video, distillation component video, so that how it works and just exactly can you see this video? to stop the screen. वीडियो दिख रहा है आप लोगों को? हेलो, कैन यू हियर मी स्टूडेंट?
नो मैम.
वीडियो नहीं दिख रहा है?
नो मैम.
इज इट ऑडियोबल? वीडियो का ऑडियो आ रहा है आपको? यस, प्लीज गिव मी फीडबैक सो दैट आई कैन प्ले, अदरवाइज आई नीड टू एक्सप्लेन. ऑडियो सुनाई दे रहा है क्या? बताओ मुझे.
नाही मॅम.
ऑडिओ येत नाहीये व्हिडिओचा.
नाही.
नाउ इज इट ऑडिबल? ऑडिबल
नाही
था?
मॅम.
ओके, ठीक है, मैं एक्सप्लेन करती हूँ. What we are going to see, distillation basic system and components. So distillation process is separation of the liquid mixture into two or more components. Components of the distillation unit. This is the feed tank, feed pump, preheater. Then this is the column of fractionator. This is condenser where the vapor is cooled, accumulator, product pump. Here you will get the top product, or it is called as a distillate. This is the reflux line, so that the product is fed back to the column. Top product is fed back to the column. At the bottom you will see the bottom product pump, where you will get the bottom product line. This is the reboiler, where the bottom product is heated again and boil up is given back to the distillation unit. You will see the working. Just give me 2 minutes. Audio थोड़ा set करती हूँ मैं. If you can hear the same audio, na, it's better. Is it audible now?
No, ma'am.
ठीक है. Vapor rises up in the tower, whereas the liquid falls in the tower. Bottom product is taken away. This is a reboiler. It is connected at the bottom. Heat is provided so that the liquid is boiled up and the boil up is fed back to the column. Vapor enters in the towel and again it rises up. This is called as a boiler. So the tower, what we require, it is required to transfer mass transfer for mass transfer. So it is provided in the boiler. This is a condenser. Vapor converted into the liquid is collected in the accumulator. Part of that liquid is fed back to the tower and other is taken away as over. You can see the sieve trays. Okay, there are no caps. This is called as a sieve tray arrangement. Openings in the trays allows the vapor to rise up. These are the walls of the tray so that the liquid can stay on the platform. This is called as a downcomer. Somewhere the liquid falls on the other. So as this process continues, the rising vapor contains higher concentration of the top product, whereas the falling liquid contains more concentration of the bottom product. You can see. Here the flashing test, so called flash zone. This is called as a rectification section, and bottom is called as a stripping section. Again, I will show you the three zones. It is important. This is called as a flash zone. This is called as a rectification, where you will get the top product, and the lower one is called as a stripping section. Now we will see bubble cap tray. This is about the sieve tray. Then bubble cap tray. You can see the arrangement. So there is a hole from where the vapor enters. Then it escapes through the gap between this tap and the wall, and it mixes with the liquid. This is another type which is called packed column. It's packed. Types of packing. This is known as the casting bore saddle. You can see different type of packing. Here you can see the layers of packing. So the gap from where the vapor escape and it enters in the next layer and so on, and also it is filled with the liquid. So it provides the space where the contact of vapor and liquid phase, and because of that the mass transfer, the rising vapor is more concentrated with the high volatile component, whereas the falling liquid is more concentrated with low volatile component. And this way the separation takes place. Okay, so this is about the working and components of distillation. I will show you the another video. Just wait. Can you see this distillation tower? Okay. This is a distillation tower and the accessories attached to it. Just go through this way. Pump, boiler, condenser. This is the tower. Smaller. So this is the distillation tower. As we studied, there are different structures. So this is a tray like a structure. Bubble capsules are there. So on which the liquid is filled and the vapor rises. So there is contact. This is one more arrangement. There are some innovative method for the mass transfer. So some modification in the caps. You can see there is cap. Okay, cap, but the shape is different. Can you hear this video? Audio है क्या? Yes or no? Is it audible?
No, ma'am.
No. Okay. Added column. You can see the tray gets filled, falls on the next tray, second tray gets falls on another tray. Boiler is added at the bottom. Vapors are moving up, whereas once we get volatile at the bottom, whereas no volatile component at the top. So because of the heat transfer, mass transfer takes place. And this process just wait, I will show one more to you. Here you can see the distillation tower along with other accessories. This is a preheater where feed is heated with the help of heating media. So feed is added in the preheater. Utility is a steam or a hot fluid. This is a column, tray column. Here the bottom product is collected and then dispatched. Condenser, where the top vapor are condensed, converted into liquid phase. This is the receiver or accumulator, where the top product is collected. Let's see the working. This is reboiler, where the bottom product is heated again and boil up is added to the distillation. When feed wall is open, feed is added to the preheater, that we will see. Now the feed wall is closed. When it is open, feed flow start, feed is getting added into the preheater, where hot utility is provided to increase the temperature. Okay. So feed is heated. That feed is added to the distillation column. It is added at the middle of the column. So it falls on the middle tray. When that tray is get filled through this downcomer, it falls on the next tray, which is below the tray. The second tray get filled, it falls on the tray. These are temperature sensors. ये जो दिख रहा है, these are temperature sensor. Thermo well is there and temperature sensor is added. So at each tray there is a different temperature. So the different equilibrium of the components you will get. At the bottom, the liquid is collected. That liquid is added to the reboiler where heat is provided, as well as that liquid is collected in this receiver. ये bottom product का receiver है. Okay. So that bottom product is taken away through this receiver. Maybe you require to reduce the heat of the bottom product. That's why cooling action is shown over there. So when the heating media is added to the reboiler, bottom liquid is heated. So what you will get? Vapor you will get. That vapor is called as a boiler and it is added to the distillation unit. So this is a feedback, bottom product. This is boiler feedback. So this vapor rises up through the column through these holes and it moves up. When it is moving up, it mixes with the liquid in the stripping section. This vapor, after passing through this condenser, get condensed. You will get the liquid phase. Some part of that liquid is added as a reflux. So this reflux is added on the top tray, right? So when this tray gets filled, it falls through this downcomer on the tray below that. So one by one, the tray gets filled and the liquid pours down. In doing so, as the vapor is passing up, it is mixes with the vapor. So heat transfer is there, and because of that, mass transfer is there. So we can say the top trays are with more constituents of more volatile component, whereas the bottom tray contain more portion of the less volatile component. So if you consider the fraction of more volatile component is more at rectification section, whereas fraction of lower volatile component is more at stripping section. So on each tray, there is a different equilibrium concentration of the components. Here, if you observe, this is the stripping section. Feed is added, simultaneously bottom product is heated, boil up is added, then you will get the vapor, that vapor get condensed, you will get the reflux is added, and the process continues. You can see the temperature gradient. As the boil up is added, initially this temperature is 82, but now it becomes 100. Then middle portion 92 and the upper part is 8. This is what exactly happens at the bubble cap tray. Vapor lifting the cap up front, and because of that there is a gap between this and the vapor escape through that gap. In doing so, it mixes with the liquid. Heat transfer, mass transfer takes place. So rising vapor is with more concentrated with the more volatile component. So this is all about the working videos along with the components. Any doubt in this, student? मैंने वीडियोस दिए हैं PPTs में, you can just go through the other videos also. Any doubt? अभी तक जो हमने देखा उसमें कुछ डाउट है? Am I audible?
No, ma'am.
Okay.
Yes, ma'am.
So these are the link for the videos. You just go through it. ऑडियो अगर आपको सुनाई देता है तो और अच्छे से समझेगा. लॉट ऑफ थिंग्स आर एक्सप्लेन्ड. 20-20 मिनट के वीडियोस हैं. So if you just go through these 3-4 videos, it will be more clear to you. Okay. The next we are going to start with types of distillation. Okay. Types of distillation. There are types like binary distillation, multi-product, batch, continuous, and some special type of distillation like azeotropic distillation, extractive distillation, and vacuum distillation. So one by one we will discuss this type. Binary distillation. How will you define binary distillation? Why it will be called as a binary? Just tell me. Well, there are only two products, or we can say feed is a mixture of the two components, and you are going to get top product and bottom product, then we call it as a binary distillation. Okay, feed में दो ही component है, A and B, so separation will give you only two products, then that type of distillation is called as a binary distillation. Multi-product distillation, when the feed component contains more than two components or constituents. For example, if the feed contains A, B, C, D, E, these constituents, then we call it as multi-product distillation. So in that case, you will get 5 different products from the distillation, right? So that is called as a multi-product distillation. Oil refineries, my distillation tower is there, and we are getting multi-product out of that. Then batch distillation and continuous distillation, these are the types depending on how the distillation process is carried out. If some particular batch is added in the distillation, that is some quantity of the raw material, some quantity of the feed is added, it is separated, and then the next batch is added. Okay, so it is called as a batch distillation. Batch में work होता है वो. Particular volume is added in the distillation tower, it is separated completely, it is cleaned, and then the next quantity is added. Continuous distillation, continuously the feed stream is added to the distillation tower, continuous distillation, that is continuous separation process is there. So maybe one tower is not sufficient, in series there are number of towers. So in the first tower you are getting just two products, a top product and bottom product, but your top product is a mixture of A, B, C, and bottom product is a mixture of C and D and E. Again in the next column it is added, so you will get separate A, B, but not C, like this. So it is not necessary that only one tower can give you the objective, that depends on the application. There may be a series of distillation tower so that you can get a separation of the component. The continuous distillation mein feed is continuously added. So in continuous distillation, it may be required than the batch distillation. So series of towers continuous अगर है application तो उसमें ज़्यादा ज़रूरी पड़ता है. Okay. Then azeotropic, extractive and vacuum distillation. These are three some special type of distillation. Azeotropic distillation, when the normal distillation process is not able to separate the components of the feed material, then we have to go for azeotropic distillation. What exactly happens, why the components are not separated? There are two reasons. One reason is the mixture is azeotrope. What do you mean by azeotrope? For example, if you add two components, suppose if you consider some two chemicals, and when that chemicals are getting added in particular proportion, it forms a third mixture, and that third mixture is called as a azeotrope. Boiling point of the two components which are getting added to form the azeotrope is different, but जब उसका mixing होता है तो पूरे mixture का एक ही boiling point हो जाता है, then it is called as a azeotropic mixture. So for azeotrope, even if you pass that feed through the distillation sorry, what you will get, the top product, the same proportion you will get, as well as for the bottom product, the same proportion you will get. For example, अगर feed में A का 60% and B का 40% proportion है, so feed contain A 60 and B 40. When it passes through the distillation, vapor is there as well as the liquid is there, right? So vapor may be 60% A, 40% B, and liquid may be 60% A, 40% B. That is, the top vapor as well as the bottom liquid contains the same proportion of the components. So You cannot able to separate that through the normal distillation. So what is required in such case, you need to add the strainer in the distillation column. So what that strainer or third component will do, that third component, it forms the heterogeneous mixture with that azeotrope, and it lowers the boiling point of one of the feed component. ए एंड बी का कुछ प्रपोर्शन था, दोनों का बॉइलिंग पॉइंट डिफरेंट था, लेकिन ए एंड बी के पर्टिकुलर मिक्सिंग से एजियोट्रॉप फॉर्म हो गया. एजियोट्रॉप की वजह से बॉइलिंग पॉइंट ऑफ बोथ द कंपोनेंट बिकम सेम. So top vapor as well as the liquid contain the same proportion. So you need to add some component in the distillation so that it lowers the boiling point of one of the component and it gives you the separation. Here I have given the explanation. I will just read point wise. First point. It is a mixture of two or more pure chemicals in such a ratio that its composition cannot be changed by simple distillation. This is because when azeotrope is boiled, the resulting vapor has the same ratio of constituents on the original mixture of liquid. Boiling point of an azeotropic is either less than or greater than the boiling point of any one of its component. For example, अगर आपने 95.6% इथेनॉल एंड 4.4% वाटर ये ऐड किया तो इट गिव्स यू ट्रू एजियोट्रॉप. इथेनॉल का बॉइलिंग पॉइंट है 78.4 डिग्री सेल्सियस, whereas वाटर का बॉइलिंग पॉइंट है 100 डिग्री सेल्सियस. बट अगर आपने 95.6% इथेनॉल एंड 4.4% वाटर लिया तो इवन बोथ द कंपोनेंट्स हैविंग डिफरेंट बॉइलिंग पॉइंट, लेकिन उनके मिक्सिंग से जो एजियोट्रॉप फॉर्म होगा उसका बॉइलिंग पॉइंट सेम रहेगा, दैट इज 78.1 डिग्री सेल्सियस. दैट इज दिस azeotrope boils at 78.1. So vapor as well as the liquid contain the same components of ethanol and water. You cannot able to separate them. So last point, azeotropic distillation refers to the specific of adding strainer component to generate new lower boiling azeotrope, that is heterogeneous. I will explain this with diagram. For example, this is column C1 and this is another column in series with that which is C2. So C1 column को feed की add किया है which is A plus B. Okay. So this feed contain A and B component. A and B, when suppose if this is ethanol 96.4% and water 4.4%. So this feed forms the azeotrope. Now when it is added at 78.1 degree, it start vaporizing. So you will get the vapor and some portion is falling down which is in the liquid phase. So ये vapor में भी A and B का proportion as well as the liquid phase में A and B का proportion same रहेगा. That's why in the column C यहाँ पे दिखाया नहीं है but component E is added. So when E is added to this column, then it forms the lower boiling azeotrope. So A के साथ उसने heterogeneous mixture form करके low volatile component form किया and that will vaporize faster than B. So what you will get? You will get pure B at bottom whereas A plus E at the top. This A plus E is added to column C2. Top में A plus E which is a feed for column C2. So here what you will get? A you will get as a top product as it is low volatile component, whereas E you will get at a bottom product. So this strainer you can use again to add it with the fresh feed. So if it is a continuous process, you will get A and B product out of this two series distillation tower, whereas strainer, you need to recycle again through this. Understood this? This is called as extract. This is called as your azeotropic distillation. समझ में आया है ये? Yes, student. Is there any doubt?
No, ma'am.
सबको समझ में आया है? Yes, no. At least some students unmute themselves and give response.
Yes, ma'am.
Then the next we are going to study extractive distillation. Another special type of distillation is extractive distillation. Extractive distillation. But before we proceed for extractive distillation, we are going to study one more term that is called as relative volatility. Okay. Relative volatility. As we discussed, distillation separates the component on the basis of the volatility of that component. For example, फीड में अगर A एंड B कंपोनेंट्स है तो A का वोलेटिलिटी क्या है और B का वोलेटिलिटी क्या है, डिपेंडिंग ऑन दैट सेपरेशन ऑफ A एंड B is there through the distillation. Now what do you mean by volatility? It is related with the boiling point of that component. It is related with the vapor pressure of that component. लिक्विड बॉयल कब होता है? जब उसका वेपर प्रेशर इज मोर देन द एटमॉस्फेरिक प्रेशर, देन इट स्टार्ट बॉइलिंग एंड कन्वर्टेड इनटू वेपर फेज, राइट? सो वी आर गोइंग टू रिलेट वोलेटिलिटी ऑफ दिस टू कंपोनेंट्स, okay, or more than two components. So relative volatility is a measure of the difference in volatility between two components and hence their boiling point. Suppose there is a mixture of A and B components. So what is the volatility of component A and what is the volatility of component B? That ratio is calculated, and if that ratio is 1, it means if both the components are having the same volatile point, then both are having same we can say same boiling point. Okay, then it means relative volatility is 1. So in that case, if the relative volatility is 1, you cannot able to separate that component through simple distillation. समझ में आ रहा है? अगर कंपोनेंट का वोलेटिलिटी डिफरेंट है, एक सपोज आपके मिक्सचर में एक कंपोनेंट हाई वोलेटाइल है, एक कंपोनेंट लो वोलेटाइल है, तभी वो जल्दी एक कंपोनेंट वेपर फेज में चला जाएगा और दूसरा लिक्विड फेज में रहेगा, राइट? अगर दोनों का वोलेटिलिटी बॉइलिंग पॉइंट सेम है तो डिस्टिलेशन यूनिट में ऐड करने के बाद दोनों का वेपर फेज में कन्वर्जन होगा या दोनों का लिक्विड फेज में रहेगा. The ratio will not get changed. Why? Because both are having the same boiling point. It means relative volatility is 1. So when there is a difference in the boiling point of the two components, then it is easy to separate that two components. But if boiling point of both the components are near or they are same, that is relative volatility is near to 1, it is difficult to separate the two components through simple distillation. Then we have to go for extractive distillation. I will read these points over here, you will understand them. Relative volatility is a measure of the difference in volatility between two components and hence their boiling point. It indicates how easy or difficult a particular separation will be. Relative volatility of component A with respect to component B is defined as if relative volatility between two components is very close to 1, it is an indication that they have very similar vapor pressure characteristics. Okay, so relative volatility is denoted by alpha. When we are considering two components, let us say A and B, so we calculate volatility of A upon volatility of B. So that will give you relative volatility. If this ratio is near to 1 or 1, it means the separation is very difficult. You have to go for some special distillation. So that special distillation is extractive distillation. समझ में आ रहा है आपको ये volatility term, relative volatility? Yes?
Yes, ma'am.
Okay. So when the boiling point of the component is almost same, it is difficult to separate the component with the distillation. We are adding third component in the distillation so that we can easily separate the components. That is called as extractive distillation. The third component is called as a solvent. For example, I will show you the diagram. Yeah. Here, look at the diagram. Can you see the diagram? This is a feed. There are two columns, you can see. Okay. This is a feed which contain A and B components, let us say. This feed with two component is added to the column. But this two component, A भी 70 degree Celsius पे boil होता है, B also boils at 69 degree Celsius. मतलब दोनों का boiling point same है, दोनों की volatility same है, दोनों का vapor pressure characteristic same है. तो क्या होगा? Once they are added to the distillation column, जो vapor form होगा उसमें भी A plus B रहेगा और जो लिक्विड फॉर्म है यहाँ पे उसमें भी A प्लस बी सेम रहेगा. द प्रोपोर्शन इज नॉट चेंज्ड. फॉर एग्जाम्पल यहाँ पे 50% A 50% B था, दोनों का बॉइलिंग पॉइंट ऑलमोस्ट सेम है, तो वेपर ऑल्सो कंटेन्स 50% A 50% B, liquid also contains 50% A 50% B, right? So how you will separate these two components? For that purpose, when that problem is there, solvent, this is input for this extractive distillation, it is a solvent. This solvent is added to the column so that this solvent mixes with one of the component. Either A से mix होगा या B से mix होगा, depending A क्या component है, B क्या component है, solvent क्या material है, depending on that you have to choose the solvent. So solvent mixes with one of the component and it forms the more volatile component by mixing it with the solvent. So suppose solvent mixes with the B component, तो B solvent से mix होके less volatile बन गया and less volatile वजह से आपको bottom product में मिलेगा B plus solvent, whereas A becomes the less volatile component and you will get it as a top product. So top में आपको A component मिल गया, bottom में आपको solvent plus B. So that solvent plus B is added to the second column, which is for the solvent recovery. So solvent plus B, when it is added, B you will get as a less volatile component and you can separate it as a top product, whereas the solvent you will get at a bottom product and which can be recycled again in case of continuous distillation. So this is called as a extractive distillation. Why there is a need of extractive distillation? Because of the relative volatility. Here the case is component का vapor pressure characteristic या boiling point almost same था, तो इसीलिए simple distillation से हमें top में A bottom में B नहीं मिला. To separate out that we need to add one more solvent, because of that हमें A तो separate मिल गया but bottom में हमें B plus solvent मिला, तो solvent वापस हमें B से separate out करना है. That's why that is added again to the second column where solvent is separated from the component B, and in this way you can separate A and B by using the series of these two distillation towers. Understood this? This is called as extractive distillation. Here one example is given. separation of benzene and cyclohexane where aniline is suitable solvent, because benzene and cyclohexane both boils almost at same temperature. So if you want to separate benzene and cyclohexane, you need to add the aniline as a solvent. Then you can easily separate benzene and cyclohexane from each other. Okay. Understood this? Extractive distillation, कुछ doubt है? I hope you are listening me.
Yes, ma'am.
Okay.
Yes, ma'am.
Then the next type is what we are studying, types of distillation. हम ये study कर रहे हैं, right? यहाँ पे हमने बाइनरी देखा, मल्टी प्रोडक्ट, बैच हो गया, कंटिन्यूस हो गया, एजियोट्रॉपिक हमने स्टडी किया, एक्सट्रैक्टिव हमने स्टडी किया. नाउ द लास्ट टाइप ऑफ डिस्टिलेशन इज वैक्यूम डिस्टिलेशन. सो व्हाट इज वैक्यूम डिस्टिलेशन? एज द नेम सजेस्ट, इट वर्क्स at vacuum pressure. Vacuum pressure मतलब क्या? Below atmospheric pressure. So why there is a need of vacuum distillation? There are some feed materials where very high temperature is not suggested. Because of that high temperature, the characteristic may get changed. Okay. So for some such application, what you need to do, you need to lower the boiling point of that component. How to lower the boiling point of component? Because boiling point is fixed for every component. But you can lower the boiling point by reducing the pressure. Sorry. So that concept is used over here. When vacuum distillation is used, even at low temperature, distillation is carried out. डिस्टिलेशन किस पे डिपेंड है? सेपरेशन का प्रिंसिपल क्या है? वोलेटिलिटी ऑफ द कंपोनेंट. वोलेटिलिटी किस पे डिपेंड है? बॉइलिंग पॉइंट ऑफ दैट कंपोनेंट. बट फॉर सम एप्लीकेशंस you cannot increase the temperature till the boiling point. For example, if you consider some XYZ chemical whose boiling point is 146 degree Celsius, लेकिन वो केमिकल 146 डिग्री सेल्सियस पर बॉईल करने के बाद उसका कैरेक्टरिस्टिक चेंज हो जाता है. सो व्हाट यू हैव टू डू, इफ यू वांट टू सेपरेट द कंपोनेंट्स ऑफ दैट केमिकल, you have to reduce the boiling point of that chemical. But how to reduce the boiling point? For that you have to use the distillation under vacuum. So when that solution enters in the column which is maintained at lower pressure, even at 70 degrees Celsius, that liquid start boiling and you can separate the components of that liquid on the basis of the volatility of the constituents, right? So what we are doing, instead of increasing the temperature to boil up the liquid, we are reducing the pressure to lower the boiling point and to boil get the vapor phase. So here vacuum distillation is used for low temperature distillation. It is a method of distillation whereby the pressure above the liquid mixture to be distilled is reduced to less than its vapor pressure. रिड्यूसिंग द प्रेशर से हमें क्या फायदा मिल रहा है? हमने वेपर प्रेशर ही कम कर दिया, बाहर का प्रेशर ही कम कर दिया, तो लिक्विड का बॉइलिंग जल्दी स्टार्ट हो जाएगा. ओके, यूजुअली लेस देन एटमॉस्फेरिक प्रेशर, causing evaporation of the most volatile liquid with lowest boiling point. So this is for the vacuum distillation. This is the diagram. Okay, this column is packed column where it is maintained under vacuum. So when the feed is added, okay, the less volatile component goes down, whereas more volatile component easily boil up even at lower temperature, and you will get the vapor phase, which is after cooling you will get the condensate and so on. Okay. Understood this? समझ में आए हैं? Yes, student. Yes, Amir, Adarsh, Akash, Arpita, Can you hear me?
Yes, ma'am.
Amir Ghare. Amir, are you there? Just wait, let me download the attendance. Okay. Adarsh, are you there?
Yes, ma'am. Yes, ma'am.
समझ में आया है?
हाँ, ma'am.
Is there any doubt?
No, no.
Okay. Akash Pandey, are you there? Mihir Pise, are you there?
Yes, ma'am.
Okay. समझ में आया है?
Yes.
Okay. Okay. This topic is very